All right, and yet another example. Okay, so again, we're given a nice integral. Well, nice is relative, I suppose. And we're given a region D that is enclosed by a certain set of lines. Okay, so again, kind of what I recommend doing is first kind of just draw those regions out. Okay, so we know we want to be in some U and V space for D star. We don't yet know what it looks like. We'll get there. We'll get there, I promise. But then we want to also go and think about our D space. Okay, and D is a lot easier to draw mainly because it's what is given to you. Okay, so if we think about this, okay, we have let's see, so we have two lines. It would be nice to know where these are going to meet, but maybe we don't know right away. So x plus 1, okay, so this is going to go something like, let's see, I'll do this line, and then we have minus 1, so they're going to be parallel lines, something like this. Okay, y is equal to x plus 1, and y is equal to x minus 1, okay, and then we have 2x plus 1, or negative 2x plus 1, and so that's going to do something like this, and then plus 4, that's 2, 1, 2, 3, 4, so it's going to be up here and go something like this. Okay, so this is, I'll just write this down, y is equal to minus 2x plus 4, and this is y is equal to minus 2x plus 1. Okay, so really we're looking at this space right in here. Okay, that's the region we want to transform to using change of variables. Okay, but for now we're stuck with u and v. All right, so, and again, just to maybe write this out, what do we know? We know that if we kind of rearrange this just a little bit, okay, move that over, we're going to say that 2x plus y is at most 4, but at least 1. And similarly, if we do y minus x, that's going to be at least, or no more than 1, but at least minus 1. Okay, so maybe this is going to be useful to us. Maybe we can say that let's maybe try, because of the domain restriction, that was one hint, maybe we can let u be 2x plus y, okay, and we can let v be y minus x, or put differently, negative x plus y, okay. So that's one system, and I did the work off on a different piece of scratch paper, but if you do solve for x and y, what I got for x is that it's 1/3 of u minus v, and then y is 1/3 of u plus 2v. Okay. Alright, so really, anyway, I did all that work, but what this is telling me is that when I look at u and v, now my space in D star is actually a lot better defined. I know that u, okay, so we're saying that this was u and this is v, right? So we're saying that u is between 1 and 4, so we're kind of thinking like dash lines here, and we know that v is between 1 and minus 1. So let's see, 1, and I need to maybe extend this down just a little bit. 1 and minus 1. Okay, and then I have dash lines there, dash lines there. So really I'm looking at this space in here, and that's going to be my D star region. Okay? Alright. So anyway, what this means for us is that we're almost ready. We need to do, okay, so we need to evaluate the double integral of, over D, of 2x plus y, e to the x minus y, dA, okay, and so we can do this, certainly, and then we're going to change this, let's see, 2x plus y, that was the same as u, and this is e to the minus v, and then, oh right, we need to get the Jacobian. Let's get the Jacobian going. Okay, so We say partials of x and y with respect to partials u and v, that is equal to absolute value, or determinant rather. I think it's 1/3 minus 1/3, 1/3 and 2/3. Okay, and so I get 2/9 and then 2/9 minus a negative 1/9, so that's 3/9 total, or 1/3. So then I get that 1/3 for the Jacobian, and I'm going to get du dv. Okay, now I need to figure out the bounds of u. Oh, just read off the picture. U goes from 1 to 4, and v goes from -1 to 1. And we're done. Oh, and I'm sorry, I forgot one thing. Nope, we're good. We're good. On the original problem, I did copy this down correctly. There is supposed to be a square here, which would consequently mean there's a square there and a square there. Okay. Otherwise, we're good to go on this example. Alright, so we have a few more examples and then we'll be done with videos.